everyone thought Honda's hybrid game was over. After sluggish sales, canceled projects, and years of near silence, the auto world stopped paying attention. Toyota and Tesla were busy battling for EV dominance. BYD was showing off its record-shattering range, and Honda seemed like just another brand coasting on old successes, a legacy name with no fresh edge. Or so they thought, because while the industry moved on, Honda went quiet for a reason. Behind closed doors, they were engineering something no one saw coming. Not a minor refresh, not a design study, but a fully functional prototype of the most advanced hybrid powertrain ever built. They call it the hyperdrive, and it doesn't just outperform their last generation, it leapfrogs the entire hybrid industry. It is lighter, smarter, more powerful, and most importantly, it is not a concept. It works, and it has already been road tested successfully. While Toyota doubled down on old hybrid tech and Tesla bet everything on full EVs, Honda quietly made a move that could rewrite the future of the auto market, because hyperdrive is not just a hybrid system, it is a turning point. It is designed to run seamlessly on both advanced biofuels and electric power. It is compatible with hydrogen integration, and it delivers up to 30% better fuel economy than anything Honda has ever produced. Honda did not just design a better hybrid, they built a direct challenge to the reigning heavyweight Toyota's hybrid synergy drive, the system that has dominated the hybrid market for 2 decades. It is reliable, proven, a workhorse found in millions of vehicles worldwide. But here is the catch. It is stuck in yesterday's blueprint. Toyota's system is bulky, complex, and built around a narrow set of platforms. Honda looked at that and chose a different path. They built the hyperdrive with true modularity in mind. Instead of just chasing more horsepower, they chased total control. A precision EVT allows the electric motor and gasoline engine to operate at their own perfect speeds. A hybrid 2 electric drive ratio, unlike anything else in production, is optimized for both city and highway. That alone delivers 30% better real-world fuel economy than Honda's previous hybrid systems. And unlike Toyota's, one size fits a few models approach, the hyperdrive is scalable. Same core design, different power classes. It can go into sedans, SUVs, performance coupes, even future hydrogen electric vehicles, all on the same platform. Toyota built a legend. Honda built a system for the next era. Now, the auto industry faces a choice: more of the same or more of the future. Because hyperdrive might not be the loudest engine on the road, but it could be the one that stays relevant the longest. If you are wondering how Honda pulled this off, it comes down to engineering precision at every level. Let's start with the groundbreaking dual motor unit. It is the most advanced Honda has ever built for a production vehicle, but raw specs are not what make it revolutionary. Each rotor uses high-strength magnetic alloys with rare earth reduction technology, making it lighter while maintaining output. That means it can survive extreme thermal stress yet cut serious weight from the drivetrain. Combine that with its high-efficiency power split system, more of the driving force comes from the electric side during city driving, dramatically reducing fuel consumption. Key to cleaner, more efficient. That is the sweet spot every automaker has been chasing, and hyperdrive just got there first. The real secret is the power split gearbox. It decouples the gasoline engine from the electric motor, allowing both to run at their own ideal speeds. It is like giving your hybrid multiple gears, and it makes everything more efficient. Inside the drive unit, Honda went even further. Instead of traditional steel components, they integrated ceramic, reinforced composites in high wear zones. These materials handle extreme heat and pressure, allowing the system to run hotter and more efficiently, squeezing every drop of energy out of both the battery and the fuel tank. None of this is theory. It has been tested and verified. The hyperdrive's gearbox can channel over 250 kilowatts of combined power without overheating, a benchmark no previous Honda hybrid has touched. Real numbers, real performance. Hyperdrive is not a concept car experiment. It is a proof of concept that works right now. This powertrain is part of something much bigger because it was not built in isolation. It is the result of 4 decades of relentless Honda engineering. Hyperdrive did not appear out of nowhere. This system is the culmination of every Honda innovation. Every win, every failure, every late-night redesign distilled into one drivetrain. Back in the late 1990s, Honda shook the auto world with the first generation Insight, introducing hybrid technology to markets that barely knew it existed. Then came the Civic Hybrid, the Accord Hybrid, the CR-V. Hybrid, each one brought new milestones in efficiency, refinement, and emissions reduction. But even Honda's latest two-motor hybrid system had its limits. Honda knew they could not just improve on the past. They had to start over. Hyperdrive is not a Civic hybrid update. It is a clean sheet design. It is the first Honda hybrid to use a fully geared dual motor architecture, the first to integrate ceramic reinforced composites in thermal zones, and the first to adopt large-scale 3D printing for core housing and cooling channels, cutting weight, boosting durability, and slashing production waste. But here is the part the public does not always see. While car enthusiasts obsess over horsepower and 0-60 times, automakers obsess over numbers, operating costs, maintenance intervals, fuel economy, emissions penalties. That is where hyperdrive flips the entire equation. This system boosts fuel efficiency by up to 30% compared to Honda's previous hybrid tech. That is not marketing spin, that is thousands of dollars in fuel savings per vehicle per year for fleet operators and daily drivers alike. At a time when fuel costs can eat up a massive share of a household or business budget, hyperdrive is not just impressive, it is financially irresistible. It does not stop at fuel. Hyperdrive's modular design means fewer unique parts and faster service turnarounds. Its cooler operating temperatures mean less wear on critical components. It uses predictive diagnostics to detect issues before they become breakdowns, avoiding costly repairs, roadside emergencies, and downtime. Meanwhile, the pressure is building. Governments are not politely asking automakers to reduce emissions anymore. They are mandating it. The EU's Fit for 55 plan is already imposing penalties on high-emission cars. Cities from London to Los Angeles are introducing low-emission zones. Even consumers are starting to choose cars based on lifetime carbon footprint. The old hybrid systems were built for an era that is rapidly disappearing. Hyperdrive is built for what is next. It is ready for 100% renewable biofuels from day one, designed with future hydrogen fuel cell integration in mind, and built to evolve into a full EV configuration when battery tech reaches the next leap. This drivetrain does not need to be retrofitted for the future. It is already there. Then there is noise, an invisible factor most people forget. Cities worldwide are cracking down on noise pollution. Noisy vehicles face fines, restricted access, or outright bans in certain districts. Hyperdrive's electric, first architecture and smart power management make it one of the quietest hybrid systems ever tested. That means smoother city driving, quieter neighborhoods, and compliance with noise reduction regulations, all without sacrificing performance. So when automakers, regulators, and consumers look at hyperdrive, they do not just see an engineering leap. They see lower running costs, fewer breakdowns, reduced carbon taxes, wider market access, and stronger resale values. That is why the industry is paying attention now, because hyperdrive is not some far-off concept. It is the sharpest economic tool the hybrid market has seen in decades. Traditional hybrid drivetrains are built using stamped steel, welded housings, and complex machining, processes that are slow, heavy, and limit design freedom. Honda flipped the script. Hyperdrive's critical components, including motor housings, gearbox casings, and cooling channels, are 3D printed using high-strength alloys and advanced composites. This allows for more intricate airflow and coolant routing, less material waste, and lighter parts with higher thermal tolerance. Even the dual-electric motor rotors are not conventional. They are crafted from lightweight, carbon composite cores reinforced with titanium edges for strength and durability. That combination cuts drivetrain weight while boosting resilience, a rare win in automotive engineering. The power unit core, the most extreme environment inside the system, uses ceramic reinforced composite CSCS, a material that can handle temperatures far beyond what traditional metals can tolerate. This means hyperdrive can operate at higher thermal efficiency, squeezing more power from less fuel. CCCs are also lighter and more fatigue-resistant, extending system life under constant load. The power split gearbox, the crown jewel of hyperdrive's architecture, allows the gasoline engine to run at optimal RPMs while the electric motors deliver instant torque, letting each component operate at its peak efficiency. This not only boosts performance and fuel economy, but also reduces drivetrain stress and makes the system modular across multiple vehicle types. But Honda did not just innovate inside the powertrain. They reimagined how the entire system integrates with the vehicle. For that, they formed a partnership that could change the entire hybrid market. Back in 2018, Honda quietly signed a deal with Panasonic Energy. The goal was to test hyperdrive as part of a fully integrated hybrid system, not just as a drop in drivetrain, but as a complete propulsion and energy architecture. Engine, electric motors, battery pack, cooling, all engineered together and optimized as one. This was not just a friendly collaboration, it was backed by Japan's Green Innovation Fund, a multi-billion-dollar government program aimed at slashing transport emissions. Panasonic knew what it wanted, a pathway to next-generation hybrid and plug-in vehicles with sustainability built in, not added as an afterthought. And Honda wanted hyperdrive on the road first in as many vehicle classes as possible before Toyota or BYD could react. It was a perfect match. Together, they are developing integrated power systems that go beyond horsepower. They are targeting noise, efficiency, aerodynamics, charging speed, and even manufacturing techniques like high-rate 3D printing and automated composite molding that can scale quickly across global factories. Tesla was not in the room. Toyota was not either. While Tesla doubles down on pure EVs and Toyota stays locked into older hybrid designs, Honda and Panasonic are quietly co-developing the future. Hyperdrive has one advantage almost no one talks about, but every city cares about: noise. Urban vehicle noise has been one of the biggest complaints in city centers for decades. Idling engines, acceleration roar, and low-speed mechanical hums all add up to daily frustration for millions of residents. Governments are responding not just with stricter vehicle noise limits, but with urban driving curfews, restricted access to certain districts, and heavy fines for violators. Hyperdrive was designed with this in mind. Thanks to its electric-first architecture, it moves under battery power at low speeds, producing almost no noise in city traffic. When the gas engine kicks in, the power split gearbox allows it to run at lower RPMs, drastically reducing combustion noise, especially during acceleration, the noisiest part of driving. The result is a massive drop in decibels without sacrificing performance. For fleet operators, that means easier access to noise-sensitive zones, the ability to operate in early mornings or late nights, and smoother approval for contracts in regulated areas. For city planners, quieter vehicles make it easier to pass pro, hybrid, or pro electric legislation because hyperdrive-equipped cars already meet the next wave of noise targets that older vehicles cannot touch. It is a subtle advantage, but a strategic one. Because as more countries start treating noise pollution like emissions, the quietest vehicles will have the loudest impact on the market. So now you have a hybrid system that is not only powerful and efficient, but also light, modular, future-ready, and quiet. This leaves Toyota in a dangerous spot. While Honda and Panasonic have quietly moved toward full system integration, Toyota remains tied to its hybrid synergy drive, a legacy architecture optimized for reliability, but not for future flexibility. Toyota's system is undeniably proven, but it is also bulky, tied closely to specific vehicle platforms and built with a narrower performance window. Some of Toyota's most anticipated hybrid refreshes have already faced delays, limited global rollouts, and reduced production targets. Meanwhile, hyperdrive was built to scale. The same core architecture can be tuned for multiple power levels. It can be used in compact city cars, full-size SUVs, high-performance coupes, and even future hydrogen electric hybrids. It is not one drivetrain, it is an entire ecosystem. That modular design opens the door to something game-changing: fleet unification. Car manufacturers and fleet operators hate juggling multiple powertrain types. Different parts, different training, different maintenance schedules. It is costly and inefficient. Hyperdrive's adaptability offers one core system across multiple vehicle lines. That means lower training costs, simplified supply chains, and streamlined servicing, all translating into huge savings over time. While Toyota continues to rely on platform-specific hybrid units, Honda now has something that can move horizontally across the market. This is not just about selling engines anymore, it is about locking in entire ecosystems. With Honda already aligning hyperdrive with global EV and hydrogen roadmaps, the writing is on the wall. The next generation of vehicles will not be built around the drivetrain. The drivetrain will be designed with the vehicle from day one. That is the kind of alignment Toyota does not currently have, and it is a gap that does not just affect one model. Lineup, it reshapes global market share. When you are an automaker looking 5, 10, or 20 years out, you see rising fuel costs, tighter emissions targets, new noise and pollution regulations in urban centers, and vehicles that need to stay in service longer than ever before. The question becomes, do you bet on a hybrid system built for the last generation of cars, or one built to evolve with whatever comes next? That is the quiet power of hyperdrive. It is not just a drivetrain. It is a platform play. This was not just about building a better hybrid, it was about building leverage. Honda now holds a key that unlocks flexibility for manufacturers, performance for drivers, and sustainability for regulators. They have done it at a time when every part of the automotive equation is being rewritten. Post-pandemic supply chains, global environmental mandates, rapid advances in battery, hydrogen, and AI-powered vehicle systems. Hyperdrive does not just tick the boxes, it shifts the playing field entirely. It turns fuel efficiency into market share, sustainability into a competitive edge, and drivetrain design into corporate strategy. Most importantly, it forces everyone else to catch up. Toyota will have to respond, Ford will have to rethink, the entire hybrid ecosystem will have to move faster, smarter, and leaner, because hyperdrive is not just here to compete, it is here to change the rules. So next time you hear someone say Honda is just a safe legacy automaker, you will know better. They did not just keep up. They may have just built the future.